So welcome back to Daily Math Concepts. You're looking at number 10 at the July 2021 paper 2. This is the last question right there. It's a matrices question. It says, calculate the matrix product. When we're doing the matrix product, it's a row by column. And a lot of times, certain things cannot be multiplied. We can double check to see if it can. So let us check if this can be multiplied. The first matrix is a 2 by 2 matrix. Second matrix is a 2 by 3 matrix. Whenever the inner numbers are the same, that tells me that yes, we can multiply. That means it can work. And then the other two on the outside will tell me the shape of the new matrix. So my new matrix will take on a 2 by 3 shape. That's what the new matrix will look like. All right, so let us go about dealing with that. Calculate the matrix product, row by column. So let me highlight what we're going to do. We're going to do the rows from the first matrix, and that will multiply by the column from the second matrix. So that's going to be the idea. Across with down. So let's go with the first one at the top. So it's going to be 5 times 2 plus 4 times 0. Then 5 times 1 plus 4 times 3 plus 5 times -4 plus 4 times 6. So that's row by column right there. The first row is finished. So I'm going to use the second row. -3 times 2 plus -2 times 0. Go again. -3 times 1 plus -2 times 3. Lastly, -3 times -4 plus -2 times 6. And they will have those. What we need to do now is just to put those together. So in putting those together, this is what I'm getting. 5 times 2 is 10. So I'm having 10 plus 0. Then I'm having 5 plus 12. Then I'm having -20 plus 24. Then I'm having -6 plus a 0, -3 plus -6, no, this is +12. So I'm seeing +12 minus 12. So let's finally just wrap this up. My final answer is going to be 10, 17, 4, -6, -9, and 0. There it is, my matrix product. Those are the responses that we're expecting you to get for 2 marks. The second question says, state why the 2 matrices above is conformable for multiplication. Well, it was a 2 by 2 matrix that was going by a 2 by 3 matrix. Now, if the inner numbers here, when you write out the order of the matrix, if the inner numbers are the same, they are conformable for multiplication. But from a more technical standpoint, this is row, this is column, this is row, this is column. Now, we want to test if they are conformable for multiplication. So if the number of column from matrix 1, which is 2, is equal to the number of rows from matrix 2, which is a 2. As long as those numbers are the same, it is conformable for multiplication. So normally, if you write out the order of the matrix, you could look at the, the numbers on the inside, and as long as they are the same, we can say, yes, it's conformable for multiplication. Next question says, determine the inverse of this matrix. The inverse of a matrix, there's a principle behind this, is equal to 1 over the determinant of the matrix times the adjoint. So we're talking 1 over 5 times 2. So 5 times -2 minus -3 times 4. So the determinant of the matrix is simply the product of the main diagonal, and we're going to subtract the product of the non-leading diagonal. All right, so we're talking about the yellow, which is the leading diagonal, product of that minus the product of the non-leading diagonal. And then we're going to put that beside the adjoint. In the adjoint, we're going to switch. We're going to switch. So the adjoint, we're going to be switching elements on the main. So the -2 comes up here. The +5 goes down there. And then we change signs on the non-leading diagonal. Let's finalize this some more. Now let's work out this here. This is going to give me a -10 and a +12 beside this. So we have to make sure that we're not making any errors. Finally, this is a half of everything that we have. So at the end of the day, the inverse is going to be -2 over 2, -4 over 2, 3 over 2, 5 over 2. So that's me sliding in this to everybody. And then we can cancel down some more. So that's -1, -2, 3 over 2, and 5 over 2. So that's the final response for the inverse of the matrix there. Next question is a vector question. All right, so we have a vector question. So the question says the diagram below shows triangle OAB in which OA is equal to R and OB is equal to S. In addition, E is the midpoint of CD such that from O to C is 3/4 OA and from A to D is 2/3 AB. All right. Write in terms of R and S in the simplest form, the expressions for CD. If I'm going to move from CD is going to be from C to A plus from A to D. So CD is going to equal to that, C to A plus from A to D. Now, be advised that we have some information here. So C to A, because we did get that from O to C is 3/4 of OA. So that means from here, this is 3/4 R, which means from C to the A is just 1/4 R. All right, that's what we're talking about. So we have that. Also, we got information that AD is 2/3 of AB. So I need to find AB in order to work this out. Let us find AB first, which is to get all of this, and then we'll take 2/3 of it. All right. So AB is equal to A to O plus O to B. A to O, we're coming in the opposite direction that we got, so it's -R plus S. All right. So moving from A to O and then O to B. We were just told that AD is actually 2/3 of that. So A to D is 2/3 of this that we just got. All right. So -2/3 R plus 2/3 S. That's what we're saying. And that is AD. So then in putting together what we have here, it's going to be 1/4 R minus, well, if you want to say plus minus, same thing. All right, so I'm just going to put the minus 2/3. Let me write this better. Minus 2/3 R plus 2/3 S. All right, so we're putting together all of that for CD. Now, we could just finalize these, all right? There is nothing for the S. So what I'm going to do is just they want it in the simplest form. So I'm just going to draw a line here. I'm going to add my fractions one time because we're adding. So a denominator is 12. They want it in the simplest form. So I could work everything together. 4 into 12 goes 3 times. 3 times r will give me 3r. 3 into the 12 is 4 times. Let me change the marker for that. 4 times negative 2r is negative 8r. And then 3 into the 12 is 4 times. And then 4 times 2s will give me 8s. Simplifying, I'll have negative 5 with a r, positive 8s all over 12. So that's my response. And anyhow you want to write this, you could put the 8s minus the 5r if you want, but it's the same response. All right, so that's that. OE. Now we're asked to find OE. So let's put it together. OE. Where is O? Where is E? O to E. So we're asked to find this. Let me put this line here. We're asked to find O, E, right there. All right. So we're asked to find OE. So I want to move from O to E. So if I'm going from O to E, I'm going to put it at the side here. If I'm moving from O to E, OE is simply from O to C plus from C to E. All right, so that is OE. Remember though that E is the midpoint of CD. We just found CD. That means from C to E is going to be a half of this. And a half of any fraction is to double the denominator. So I'm going to use that when I'm ready. OC was already given. It's 3/4 R. And I'm going to be adding CE. CE is the middle half of CD. Half of any fraction is to double its denominator. Watch me write back the numerator. And then I'm going to turn the 12 into 24. That's half of it. Now, what we can do now is to simplify this, all right? So we want to simplify every single thing. So I'm going to be working with my 24. 4 here into the 24 is going to go 6 times. So I'm going to say 6 times 3r, and that is going to give me 6 3s, 18r. 24 into itself 1 time. So 1 times everything on top here will be itself. So we'll get negative 5r plus 8s. Finally, 18r minus 5r is 13r, positive 8s all over 24. And that is my response, easily walking through it. And that is OC. The last question says the OE should have said up there. The last question is the point O, Q, and R have coordinate 0, 0, 5, 2, and negative 4, 1. Negative 1, 4. We're looking at those. Write OR as a column vector. OR. If it is a position vector where everything is from the, as you could see, everything is from the center there, then this will, that point there, which is negative 1, 4, is automatically my position vector OR. OR is equal to negative 1, 4. So we just turn that coordinate into a vector, all right? All right, let's look at the next question. It says, oh, the magnitude of QR. Let us see what QR is. Well, QR is to move from Q to O plus O to R. Now my QO, because this vector OQ here is 5, 2. All right. So OQ, you could see it's 5, 2. But if I'm going the other direction, I will have negative 5, negative 2. And I'm going to be adding that to OR, which was already negative 4 and a 1. If we add these together, negative 6 plus 2. All right, so negative 6, 2. Now, the question never asks us for the components. It asks us for the, so we're going to be employing now, we're going to find in the magnitude of QR, which is to take Pythagoras theory, negative 6 square plus 2 square. We're getting 36 plus 4. And that's the root of 40, because negative 6 squared give us 36, and the 2 squared give us 4. So we have 40 under here. So the root of 40 is the answer, and that is good when we're dealing with vectors. So the root of 40 is the answer. Thank you for watching Daily Maths Concepts. Please like, share, subscribe, and drop some comment, right? And look out for the next videos that are coming on. Thank you.